Here's a question that most of us have been asked at some point in our lives: what's the shortest distance between 2 points? By default, most of us will give the same answer that Archimedes gave more than 2,000 years ago: a straight line. If you take a flat sheet of paper and put 2 points down on it absolutely anywhere, you can connect those 2 points with any line, curve, or geometrical path you can imagine. So long as the paper remains flat, uncurved, and unbent in any way, the straight line connecting those 2 points will be the shortest way to connect them. This is precisely how the 3 dimensions of space work in our universe. In flat space, the shortest distance between any 2 points is a straight line. This is true regardless of how you rotate, orient, or otherwise position those 2 points. But our universe isn't made up merely of 3 space dimensions, but of 4 spacetime dimensions. It's easy to look at that and say, oh, well, 3 of them are space and 1 of them is time, and that's where we get spacetime, and that's true, but not the full story. After all, the shortest distance between 2 spacetime events isn't a straight line any longer. Here's the science of why. For most of us, our first exposure to the idea of a straight line being the shortest distance between 2 points comes from a place we might not realize: the Pythagorean Theorem. You might remember the Pythagorean Theorem as a rule about right triangles, that if you square each of the short sides and add them together, that equals the square of the long side. In math terms, if the short sides are n b while the long side is c, then the equation relating them is a squared plus b squared equals c squared. Think about what this means, however, not from the perspective of pure mathematics alone, but in terms of distances. It means that if you move through one of your spatial dimensions by a certain amount a, for example, and then move through a perpendicular dimension by another amount b, for instance, then the distance between where you began and where you wound up is equal to c, as defined by the Pythagorean theorem. In other words, the distance between any 2 points on a plane, where those points are separated by a in one dimension and b in another dimension, is c, where c equals square root a squared plus b squared. In our universe, of course, we're not restricted to living on a flat sheet of paper. We have not just length and width, or the x and y directions, if you prefer, dimensions to our universe, but depth or the z direction as well. If you want to figure out what the distance is between any 2 points in space, it's the exact same method as it was in 2 dimensions, except with 1 extra dimension thrown in. Whatever amount your 2 points are separated by in the x direction, the y direction, and the z direction, you can figure out the total distance between them just the same as earlier.